My name's John Moore. I've been on the scene for a couple of years now. It's my first time at DerbyCon. I kind of try to take the approach of, we have a lot of problems in security. You guys know that. A lot of you guys know we can make a good living, try to fix those problems, try to come up with solutions. Some things seem to come back over and over, recurrent themes. So last year I was kind of looking in more of, I call it more of a war walking, stroll trolling, with the robot, and I was more looking at what we can do when we extend tools in an Android environment or a tool set, right? Pen testers, this could be helpful for you. This year I realized that we still have this horrible, horrible problem with passwords. So what I decided to do was just kind of take it on as a project. I call it the Password Intelligence Project. And effectively I'm going to kind of run through from the beginning of what passwords are, how they came about, what they do for us, how they get exploited, how we can go about fixing some of the problems passwords cause for us today. So as you see, this is a hybrid track. I like to give you guys kind of a break fix. I don't want to scare you without some type of resolution. So I give you guys some viable options to our alternatives to password technology as we know it. So what I want to do is start off by talking about the current problems in the landscape, move into what single-factor authentication is versus multi-factor, right? This is something that's really starting to come on the scene. And discuss the tools, techniques, and practices that the bad guys or the pen testers use once they get in your network based on these credentials. Then we're going to talk about recovery resistance methodology. So if I show you guys, I take a tools approach. If I show you how the tools work, and I'm going to actually use an old tool, Cane Enables. Have you heard of it? Okay, but there's new tools. I like NetCat or Hashcat now. You guys heard of that one? Okay, it does really, really good with multiprocessors, but the exact same methodology is right to use. John the Ripper, you can name it. There's probably 20 others out there you can name, but they all still work. Okay, and the question is why. So we're going to kind of look at how the tools try to take over and recover passwords, and then we can look to how to stop that recovery from those tools. And so that's kind of the perspective this talk comes from. And then we're going to kind of speculate about what the future of technology is in terms of passwords and authentication. But you know, we're going to talk about solving these problems. We'll talk about how to keep your hashes safe, multi-factor authentication, some options. So we're going to go through the whole thing. All right. So again, this is one thing I realize is people go, password, we're not password problems. Well, if you look, we see some of the big players out there have been smacked by this. Okay. And some of the reason they only found out is because when they started cracking passwords, like LinkedIn, some of the words came up like link, work. This was their passwords, four characters. That's a good password, right? So they started realizing, oh, well, maybe this is LinkedIn, or maybe this is eHarmonies. Now, these actually both got released together. So we've seen that in 2012, it's believed to be leaked by a Russian hacker, and 165,000 passwords. Now, they believe that this hash had millions, well, they know that this hash had multiple millions of passwords in there. So I think it was like over 8 million passwords between LinkedIn and eHarmony. In the first week, 165,000 of those were cracked already. Okay? Now realize these were encrypted. They got cracked. So the question is, why were some getting cracked and not the others? So we'll go out to discuss that. Yahoo, the same thing. They had one leaked by a group called Deeds. 100,000, and these were clear text. So those are just flat out, if you get the username and password, you walk up to Yahoo, you sign in, got their credentials. All right, that's even more horrific. They didn't even have it encrypted and hashed. Okay. Twitter, I was doing a podcast on February 1st talking about this talk, the makings of this talk, and we were talking about how multi-factor can help us. And sure enough, on February 1st, Twitter got hit too, okay? So we're starting to see even the big companies are getting hit by this, all right? Now, again, I said I like to bring up the things that are problems. You guys heard of the data breach investigation report put out by Verizon? This was their findings. 76% of the network intrusion exploited weak or stolen credentials. All right, that's saying that the bad guys are getting in, not by the other 24%, but because we're having problems with passwords, right? So we need to fix this. This is a huge gaping hole in our security, as we can see through things like the data breach investigation report. All right, so let's kind of walk back and talk about how it all started, right? Someone down the line, someone said, we need multiple people to sign in, we need some management, let's put passwords on them. And they go, okay, well, how do we manage passwords? Well, we're going to have to store them locally. Because, well, this was when they first came out, there was not an always-on mentality like Microsoft is starting to develop, okay? So if you were not connected, your password wouldn't work. So you had to keep it local. Well, some smart admin, maybe people in this room, said, you know what? With the right credentials, I can go in there and just access everybody's password. All right, so let's fix that. Let's hash these passwords, and then when you put in your password, we'll compare it to a hash. If it matches, you're in. If you're not, okay? So this is kind of how it all built up from scratch, right? So this is how we started. Now, this is kind of an example of how these passwords get hashed, and you can use any hashing mechanism. I'm just referring to SHA-1. This is one I pulled from eSides. I could have done it for DerbyCon. And this is a SHA-1 or an MD5 hash for those, okay? So that would be my password, and for that to match, I have to type it in the keyboard. It has to use the exact same hashing algorithm, make whatever its value is from there, compare it to the hash that's in the database. If it matches, we're good. If it doesn't, we fail, right? So this is the process right here. We type in our password, and here we can do DerbyCon, whatever our password is. Again, not a good password, we'll talk about that. And if it matches, we give access. If it doesn't, it just prompts you again. So for you programmers out there, it's a very simple loop. Okay, so now let's talk about the constitution, what passwords are created by, right? So again, they're there to act like a deterrent to let us in or not. But really, when we think about it, most passwords these days are alphanumeric. So what do they consist of? Let's break it down to its parts. There's 26 lowercase, 26 uppercase, 10 numbers, and then usually around 33 special characters. If you're doing web banking or any type of like web portal, you may be limited because some of those characters can interfere with the web app itself, right? So they kind of limit you. So that's not great because there's actually banks out there they'll limit you to 10 passwords, and they'll say upper, lower, and numbers. Now that's already limiting us because our character set right here, we're saying it's 95. And again, this is a basic mathematical permutation problem, okay? So anytime we weaken it or we take some of those out, we say we're weakening the complexity. Is everybody familiar with that, right? That sounds familiar? Okay, good. All right, so passwords effectively work like this. Let me show you the breakdown. It's pretty straightforward. So your entropy, or all your possible combinations or permutations, come from the strength of the password. So your total comes from your complexity raised to the length. Okay, so if your password is all alphanumeric, your complexity would be 10 characters, 0 to 9. You guys following right now, right? If you did, for instance, a phone number, 7 characters, it would be 10 to the 7. Like here's a phone number. These are all the possible characteristics. Now that actually isn't a 0 and not a 1 because you wouldn't count no password. So you don't actually go down to 10 to the 0 because it would assume no password, okay? So that's the math. Now you can see as we start moving up the chain, we get larger numbers. Look at this, really quick. Even though when I use the same number just by going up in complexity or adding it to the higher level, I come up to a huge amount of possible passwords, okay? So if you ever want to look at your password, this is a good way to do it, okay? Also, another trick I use, instead of calculating this whole thing out, I'll just add 1 to here. I'll do L plus 1. And I'll add that because I always know that my possible permutations will be under that. That's considered a ceiling equation. You guys follow me on that? Okay. All right, so now we know how they work. We know where they come from. How do we recover them? How do the bad guys recover them? How do pen testers recover them? Okay? Now there's a lot of tools out there. Like I said, I'm going to use just because I like the GUI. It gives me a chance to show you guys what I'm talking about. I'm going to use Can Enable. You can use Hashcat. You can use John the Ripper. John the Ripper is integrated in things like Armitage. Guess for that? Built in. Does wonderful things for you, okay? But it doesn't really do what I'm looking for. But there's others out there. TAC Hydra. We see a lot from APT attacks or from some type of remote dump. They do PW dump where this is going in and just grabbing the credentials and running off, okay? And I want you to think about if they grab credentials from a domain controller, how many usernames and passwords can be kept there? All of them, thousands, right? A lot, right? Okay, so just keep that in mind moving forward. All right, so let's fire up the tool, and I want to show you some things, how it works. All right, here's the tool fired up, pretty straightforward. And what I've done is I've just gone in and I've grabbed the local hash from the SAM, and I've thrown it out. Now, it will not store the credentials in clear text. It does it in our hashes. Here's our LM hash or our NT hash. Now, if you do any type of Windows hardening, we want to turn LM hashing off. Have you guys heard about this? Okay, we'll show you why in a second. All right, so a couple things that I learned right out of the gates. All right, so I got all their names, but it knows that some of the passwords are under 8 characters. This is really peculiar. Does anybody know why it's doing that and how it's doing that? It actually comes down because LM hashing is enabled. Anybody know?
It's split in two.
Excellent. So it is actually, what it is, it's an older protocol, or an older standard, and it effectively said if your password is over 7 characters, give them another chunk of memory to store their other 7 characters. So your password could be up to 14 character long, but it doesn't store it as, based on our equation earlier, where it'd be, say it was a number, it wouldn't be 10 to the 14, it'd be 10 to the 7 plus 10 to the 7. Right, you math people out there, you know those aren't the same numbers, okay? So I can get a lot of cracking power if I come across a machine that has LM hashing enabled, and we'll go through that in a second, okay? But that's still very cool because just by seeing how big the memory size for it is, I can tell whether it's under 7 characters or over 7 characters. But when it cracks it, it's going to crack it in groups of 7. So your password is never stronger than 7 characters when LM hashing's on. Okay, so if you have a 14-character password, which you can store, it's going to be 2 groups of 7. It'll break it down like that. I'll show you guys that. All right, LNT is the successor, and it actually does allow large stores, about 50 characters less, right? So you can have no problem with that. And that is truly the complexity as you think about it. If you had a number-based set, it would be 10 to the 14th if you had a 14-character password, and it was numbers, okay? So that gives us a lot more complexity, stuff we want to look towards. All right, so I just explained to you guys kind of how this works. All right, now, there's already a couple passwords hacked here. Let's go through them. All right, so if I'm going to recover this, if my CEO forgets his password, and he goes, I need to recover it, all right? Now, actually, I'm going to give some tricks external to this because I'm going to look into his psychological profile of passwords, and I'm going to tailor it to it, and I'll show you how to do that in a second. But right here, I'm going to go by through, and I'll say I dumped this hash. I dumped an AD hash, and it has 115 passwords, which is what I used as the data set for this. I created 115 random, pulled them in through script, and just ran through them. So the first thing I'm going to do when I start doing brute force, and this is the concept where I'm just going from A to Z, AA to ZZ, and moving down the line, okay? I'm going to start off with numbers, because I can crack to larger links quicker when I have such a small amount of characters, okay? So it's small amount of permutation. Now, does that mean I'm going to catch every password? I want you guys to think of phishing. If you go phishing, it doesn't guarantee means you're going to catch something. It's not called catching, it's called phishing. But if you go there enough, you can find out the spots where you're more likely to catch fish. You guys follow me? Okay, so I might start off with 10. Now, I may not catch all of them, but out of 1,000 passwords, maybe I pull 1. Okay? Now, what a red team member will do is they'll log in through that, or an APT, they'll log in with that, they'll escalate privileges against that account, and then they'll pivot in your network. Okay? So they didn't need an admin account, they just need 1 account to get in. And based on what I'm going to show you guys, statistically, it's very easy to achieve. Okay, so say you say, all right, well, instead of going through from the highest to the lowest, and you guys can see it's going to be hardest to crack the 95 character set, it's going to take a long time, you're going to need powerful computers. We can just say, all right, fine, let's just use a dictionary. In fact, this is quicker. This is what I would do before I even went into the brute force, okay? So this is actually the dictionary that's included with it. Now, you can see it's not a normal dictionary. There's special characters in the beginning. They had Oracle spelled with zeros because sometimes Oracle admin like these. In fact, this is set up to know certain passwords that people use. And if you go online, you can find tons of dictionaries out there per industry. So if you're looking for healthcare and you're looking to do some pen testing into your healthcare environment, you could pull a dictionary that's all words for healthcare, okay? Now, this is really interesting because I want to show you what it does. When it goes to the dictionary, first it goes through as is. Okay, that's pretty straightforward. But it will also reverse the password. So if any of you guys have a password, why don't you think of your passwords and see if they would meet the criteria of not getting caught under this system. If I reverse the password, that counts. So you see password becomes DressApp, all right? Double password. You think you're really slick and you're going to put your password in twice to give it that extra length? It's going to get it. If your password's cafe 12 and you go cafe 12, this will catch that, okay? Because it's built into it to try it. Lowercase to uppercase, it will try as lower, upper. It will go through permutations. It will try actually going upper, lowercase permutations. So if you think you're slick for putting the 5th letter as cat, and it's in a dictionary, it's catching it, okay? It'll even catch elite speak, where it will actually substitute numbers for the letters. So if you think your P at $W0RD is safe, it's not, okay? So this is what we do. We also see, this is a good one, and people do this, think a bunch of password. How many people put a number at the end of their password? So, Fluffy my dog, Fluffy. I'll make Fluffy01, that's secure, right? Okay, that's gonna get popped by this. All right, so you can see that, it's effectively going through that. So what I want to do is make sure you understand when you're making your own passwords, don't add anything that will catch this. Don't do it twice. Don't reverse it. I'm going to actually give you guys an enclave protected defense in depth strategy of how to create passwords based upon this. It'll make it a little easier for you. But again, you see how the tools crack it, beat the tools, and you beat your system getting recovered. Remember, passwords are not reversible. They have to be guessed and then matched, and if you match, you win. If you don't match, you move to the next one. And if we can hide it as a needle in a haystack of needles, it becomes much harder versus a little flag and a beeper on it, okay? Shouldn't be easy. All right, so I throw the dictionary tag on, again, 110. I find 4 right out of the gates. All right, now look at some of these. Some of these are hard. Luminescent is not a small word, but it's in the what? It's in the dictionary, so it gets spanked. It's gone, okay? So now I have 4 ways to get into this network, not just one. So if I screw up something with escalation privileges on the first guy, don't worry, I got 3 more tries, okay? So again, now you got to think statistically, you may have a good password, but for your entire company, does everybody in the company have a good password? Would they make it through this? And the answer is more than likely no. So we see why 76% say we have a problem. Now, even Moxie Marlin spikes in on this. I don't know if you guys know who that is, but he's a big name in the industry. And he's created a tool called Cloud Cracker, which is effectively just a giant array of fast and powerful machines. And it can actually go through a dictionary with a very big, so what we got, millions, billions, trillions. Goes through 385 trillion words, okay, in about 20 minutes. Costs you about $17. And that's how much it might cost you to get into their network, okay? Now, actually, I got yelled at for this first time. I gave a talk very similar to this because they said, Amazon, we as pen testers use Amazon. We can crack your password for 50 cents or less. They brag about it, okay? Using these same techniques. All right, so I started to ask. Now, the thing that makes password cracking difficult these days comes down to the fact that we don't have the power to go through all the possibilities, right? There's a movie where they have this remote control and you hit the fast forward button and things fast forward. Now, if we actually did that for our brute force attempts where we're trying everyone, if we had a fast enough computer, we go through every possibility until we find it. So the key for a good password is to make it difficult. All right, so if any of you guys or know anybody that uses pure numbers, so this is running, just so you guys know, I used a low-end machine that had a virtual machine running, so it's already splitting CPU power, and on average, I was cracking running about 8 million passwords a second. Okay? So I am really throwing some power at this, and I don't have power to throw at it. Now, if you take Hashcat, throw it through 10 graphics cards, you're going to get performance way better than that. Okay? And so you're going to be able to crack more. But I'm looking at this machine, I'm saying the average individual, putting their stuff in, is there anything here that they're going to get cracked or not cracked? So if you're using just numbers as your password, up to 11 digits, takes 4 hours or less with this machine. I'm going to get your password, or the bad guys, or the red team's going to get your password very quickly. So you can see here, it took only 2 minutes for this, ancient program to break that's a 9-character password. 10-character to 22, and because this is factors of 10, just keep adding a factor of 10 to understand numbers. It gets a little tougher as we move up to the other ones here. So here's lowercase. Notice it only starts to become intractable at what number? What number of characters does the password start becoming more difficult to break? It starts becoming like swimming through jello. What is it? So 10. And in 2 years, I probably won't be able to say that anymore. It'll probably be 11. Probably be 12. Okay? So I argue, as much as you may not want to, I suggest a 12 character password or higher with full complexity, okay? Just to make sure that even if someone's running some type of cloud cracker or some type of, say, state-funded machine that could have millions and millions of processors on it to make it difficult. But for us, about 10 characters is it. So minimal, if you can handle 10 characters, you're going to give them a fight. All right, once you get some complexity. So for all of them, we see that really right about at 9 characters, it finally goes into the green for us. So think 10 character passwords or higher. Please do not adhere to 8. Well, this is a very old and almost arbitrary story behind how 8 characters took place. So, you know, again, time moves on. What else do we have to crack it? Now, we also have this tool called rainbow tables. Have you guys heard of rainbow tables? And so one of the tricks that encryption experts do is they go, we're going to slow you down. You got those 8 million password attempts per second? What if you have to churn through the algorithm to get there 10,000 times? It's going to make it really slow on you. So some smart people out there decided, you know what we can do is we can pre-calculate all those values. We'll go through that million times. We'll pre-calculate the hash. And effectively, we'll have a dictionary of already calculated hash values. And now we're going to really just do a dictionary attack against you based on hash values. If we find it, we have some major book out there that says this hash equals this password. You guys follow me on that? But there are problems with rainbow tables. The problems come down to space. So if you look right here, I have an NTLM, which is the stronger type of password encryption, using lower alpha and spaces from 0 to 9 characters, 12 gigs. Pretty big file, okay? But as soon as we go to 1 to 8 characters, which is a smaller amount, but it does mixed alphanumeric, we're at 104 gigs, okay? Now you gotta think about it, if I move to 9, that's gonna go up by a factor of, you know, assuming it's alpha mixed numeric, so that's at least 62 more, so take that number, 104 gigs times 62. You start talking terabits, okay? So there's this trade-off between how big of a rainbow table you can handle on your machine based upon how much you can crack, okay? So we see it's literally a time-space trade-off that comes from this tool or technique. All right, so then we got through dictionary, we understand the concept of brute force, we got through some of these super crackers. So how do we weaken the passwords? How do we make it so that if you are using that 13, 14 character passwords, how do we weaken your password so possibly it can be recovered, all right? So I'll show you a trick. Now, this is one of my early dives into password recovery. I go, okay, I would be slick. I know the password policy at this company has to be 8 characters or more. So I'm going to pull out any searches from 1 to 7. Sound pretty good? It's pretty straightforward. When I do that, I actually removed 3 trillion possibilities. That's a big number. I don't have to go through them now. Okay, because I know it can't be those because it won't be 1 to 7 based on the company policy that I'm doing the pen test for. All right? But if you look, I've only degraded it by what? 2%. That's nothing. Right now, it might as well almost be the same. Okay? So what else can we do? We've got to have some other strategy. All right, now this is where we're getting some of the new work on this problem. All right, so August Dvorak, back in 1936, discovered that when we type, we don't type with the same frequency on our keys. Pretty straightforward. The other thing we have a tendency to do is when we make passwords, we need to make them memorable. So they fall into English rules or whatever language you use, okay? So common characters will become in a statistical structure where we have 100 or 1,000 or 10,000 passwords. We can leverage our knowledge of statistics of keystrokes to make it so we have a higher probability of getting their password. So if you look right here, our highest, this is from highest to lowest. What do we hit the most on the keyboard? All right, now I want you guys to think Wheel of Fortune. Okay? What do they do if you guys go for the final prize? They actually start you with letters. Why are they starting you with letters? Because for their game, what? It's the ones that everybody asks for. Okay? So I already showed you guys the strength comes from having this huge set of characters. And I also said if you go fishing and you know the lake, you may know the area to fish to go and get the most fish. So what if I just took 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters and ran them through? What do you think? Do you think if I have 1,000 passwords, do you think based on the rules that I may get some? Okay. Now I actually did it off of a random key set. I had 114. I only pulled 1 password doing that. But guess what? I pulled one more than I did before that, okay? And all I need is one to get in, all right? So, oops, sorry. So here I'm doing, and I'm just removing, that was a very extreme key set space shrinking technique. This one I'm just going to take off the far end, the one that rarely get used. So if we look back here, you can see there's ones hiding like Z and J that don't get used that much. Okay, so I'll pull those off. All right, and what you can see right here is that here I'm going to an 8 key space, here I'm going to a 9 key space. Look at the time between them. They're almost identical because I've weakened the possibilities. Now here's the catch. If any of those passwords I'm trying to hit have these letters in it, I'm not getting them. But I don't need all of them. I just need a couple. Okay, actually just need one. All right, and so that's the key is when we have statistics on our side, we're almost guaranteed to get it. All right, now look how this works, and this hopefully will change your mind a little bit of how you make your own passwords. So think of Mississippi. It's a pretty big word, all right? But if you really look at Mississippi, it only constitutes how many letters in it? 4. So if I go into my character space in my program for cracking, and I can take out everything except for its constitution of 4 characters, it will then crack it for me. So all I have to do, sorry guys, is type in MISP and go on all the passwords. The one count that had Mississippi for its password gets hacked in 1 second. Okay? Now if I would have left it in there, what we assume, our presumed key space says that's going to take 13 years. Okay? So, but now, with just grabbing just the character's amount, bringing down that key space, we have now turned into 1 second. Okay? So, a lot of us still are in the thinking of presumed key space. Oh, Mississippi, that's a good word. Okay? And again, I'm only going off 26 characters. If we assume upper and lower case, it gets even bigger. All right? So, effectively, what I want you guys to start doing when you start thinking about your passwords, start thinking about the complexity or the uniqueness that lives inside your password. So, quick example, Utah and Ohio, under our old school thought, would say, these are equal. They're not equal, because Utah has 4 unique characters, which the math would be 4 to the 4, versus Ohio, which would be 3 to the 4. You guys seeing this? Okay. All right. So effectively, when you set up your passwords, make sure you guys are setting up passwords that don't follow all the rules we talked about before, doubling, numbers at the end, and also try to make sure you don't use words that have a lot of repeat characters in them. They're going to make it easier to get caught with tools like this. Okay, so there's been a lot of options, or a lot of situations that have occurred historically. I believe his name is Aaron Barr, you could speak to this. That the fact that sometimes if you use the same password elsewhere, bad things can happen to you, okay? So you get a lot of times people say, look, passwords are our digital kingdom. They're the keys to get in, right? So we have a ton of passwords, and people will go, I gotta remember so many passwords, I'm just gonna use the same password for everything. Not the best idea, because effectively, you've given someone the master key to the schoolhouse, right? So the janitorial key that gets in all the rooms. That's what you're doing when you're setting it up. But you go, hey, look, it's too hard to remember. So what I want to do is kind of give you guys some thoughts about how you can create unique IPs for every device, unique passwords for every device, but have something to do with the site. So I call it a virtual second factor, okay? So, for example, if you have a Gmail account, now these are very obvious examples, but that's what they're supposed to be. So, GMA versus my Yahoo account, all right? And on this one, I decided to be tricky, is I took what I do is from every website that I have a password for, I don't do it, but you could. You put the first 3 letters, I don't like to be as my passwords. First 3 letters of the site I'm on. So if this is, say, Hotmail, it might be hot, it might be something, I might pick a key to the right of each letter of hot, right? But I use the same algorithm for every site, okay? Now, some other things we should do is some special characters, because what we saw earlier is that if I throw out the special characters, I might get some of those passwords. So by doing the special characters, now we're making it that the fish are in a different part of that pond, and they're not going to catch it. The other thing I do, so originally, so let's say this was Grandma's password, it was Fluffy, and she made it strong by making it Fluffy1, and we had to tell Grandma, no, that's not a strong password, and then we try to explain, well, this is your Gmail account, so let's set it up where you build in some information here. So if this one gets compromised, this one may not. And again, you can see that through here. So we're getting complexity, we're getting length, okay, and you're getting a way to remember your passwords, all right? So it's almost an off-the-grid type strategy, all right? Okay, so if you say, look, John, man, I can't remember a password. Even if I do the same rule for everyone, I can't do it. All right, well, the good news is there's tools out there that can help you. All right, so if you are password remembering a challenge, you can choose one of these. Now, a lot of these have costs associated with them. What these are effectively just a vault service where effectively they keep your passwords for you. They have their own issues because someone can compromise their site and their databases, and then your stuff becomes available. But there are some that actually will hash things on your machine. The trade-off there is that if your machine dies and you forget your password or the hash, you're not getting anything back, okay? The bad side on the other side is that if something gets exploited from their side, they may not tell you, and your information could be out there. So if you guys want to keep it cheap, KeyPass. Works for pretty much every operating system you have. RoboForm, a little more expensive. If you've got the money to blow and to burn, about 30 bucks. LastPass, pretty decent, about $1. Okay, Splash ID, 19 bucks to 9 bucks, depending which one you're using. And 1Password, if you are one of those, if you are a Mac fanboy and all you use is Mac, you have some options as well. All right, so again, I wanted to show that this was 2012's list of worst passwords. So you guys think you have a bad password? No, you don't. Those are them right there. And effectively what these were the most cracked passwords. All right? Now, I want to know what's in the psychological makeup of people that they decide monkey is their best password. I don't know, but monkey is in there. All right? Dragon, sunshine, and if you really love someone, you write I love you as your password, right? This is all bad stuff. Okay? And again, notice it follows, these people's passwords are following all the rules we talked about earlier, being in the same structure of language, which means that all the statistics we talked about keystroke probability would play out here. Okay, so what can we do to fix this? We got some issues, right? So one of the things we can do is I like to take I love security awareness, but I would rather be able to give security on the enterprise side and not on the user side. I don't want to rely on the user. Can it help that the user knows to make strong passwords? Absolutely. But what if we can make them use strong passwords? Does that matter? I think so. It's up to you. I mean, hold it yourself. But bcrypt is a tool out there. So if any of you guys are developers out there and you want to keep your password safe, you can actually download this. This is a program that has a Java, Python, C, Ruby, Perl, the list goes on of implementations. And what it will do is it takes those encrypted hashes in your SAM and it will salt and encrypt them. So it will be double encrypted. So if someone does steal that password file, they're going to have to first hack it to get it to show the true values of the hashes. So effectively a two-step process, which makes it much more difficult because, as I said earlier, I want to beat the tools. As soon as it comes down to bcrypt, all these machines go, or all these tools from Hashcat on down go, I don't know what this is, I'm broke. So first, that's already making it tougher because now you have to have someone that has the skill set to be able to try to run back through this. And what they did is they used Blowfish, and you guys know Blowfish. It does a lot of iterations. It's very slow, okay? Again, we could probably use something like a rainbow table on it, but again, it takes lots of time, and it would be 2 steps. So that adds a lot, and the implementation's already there. All you have to do is add it to your system with whatever programming language is your favorite. So something to think about. These are interesting. This was a new concept that came up from a guy from RSA. I think it was a Rivist. I actually don't want to lock into who did it, but effectively this is cool. What they did is they came up with the concept of, what if you put fake accounts and then you look to see if they've been accessed? Oh, that's kind of cool. So Mickey Mouse is in your system. He's never logged on before, but he logged in last Thursday. Your passwords are compromised. So like a honeypot, but with passwords. Okay? So cool concept. The problem I don't like with it is that if it's a legitimate account, even if you give it no privileges, what I said earlier is your pen testers are going to escalate through hacks anyways. So you've given them, even though it's a fake account, if it has real access, even though it might just be a guest account in terms of what's behind on privileges, if they can escalate, it's still dangerous. Okay, so something to think about if you guys want to use it. The other thing is that you have to monitor it. You don't know your honey passwords are breached unless you keep checking. So there's going to be that aspect to it as well. Cool concept. All right, so for us to kind of push past where we are today with security, we're going to have to understand there's multiple types of authentication out there. So you guys are used to what you know. That's the one that you're locked into, what you know, right? So I'll say log into your Gmail account. Unless you guys have two-step on, which we'll talk about in a second, you're just going to put in your password and go. Yahoo, same thing, right? So there's actually 3 different types of authentication. If any of you guys are, this is probably old hat for many of you, but some of you might be new. What you have is one, what you know is the other, and the last is what you are. And everything we have falls into those 3. Okay, they're actually throwing around possibly a 4th one based on reputation. It hasn't picked up yet, but I just want to let you know about it. All right, so wristband, ID card, security tokens, software tokens, phone, cell phone. These were all what you have. Excuse me. So, for instance, if you are using a RSA token, anybody have one of those? Okay, yeah. So that is adding 2-factor. How does it add 2-factor? You got to have a token, right? And then you got to have a pattern or your password to go with it. Make it a 2-factor. Now, so let me give you guys one and tell me what it is. How about your blood vessel signature? What would that be?
What you are.
What you are, right? Good. And again, there's some horrible scenarios that go on with things like what you are. So for instance, I believe there's a car, I think in Taiwan, that got stolen. And how it got stolen is they put the guy in the back alley and they cut off his thumb and they started his car with his thumb, okay? So they only get 2 tries to do that, but 2 more than I want. All right. So some problems with that. Again, other ones, what if you did a retinal scanner, you put your eye into it, everybody in the company does it, tomorrow everybody has one pink eye. Things to think about. All right. What you know, what you have. Okay, so let's kind of bring them together, make sure we understand them. Now, if you go into Google, and does anybody have a soft token where they actually go into Google and it says, I've never seen you before on this computer, I need you to give me a value that's going to pop up on your cell phone. You guys seen this? And they call it 2-step, but it's actually 2-factor. Okay? Why is it 2-factor? Because it's something you have and something you want. So it makes it 2-factor. Now, if you said, I've seen this before, I've seen engineers go, we're going to make it really strong. I'm going to put a password at the BIOS and a password when you log in. Okay? Now you've still just locked yourself into 1-factor. So you created a 2-step authentication, but you haven't given the strength of 2-factor. Does that make sense? Okay, so if you do password twice, or if you did your thumbprint twice, that would be 2-step, okay, versus 2-factor. So it's good to understand. And again, I show you guys here, if you did something you know twice versus something you know or something you have. Okay? Now what we see is that all our password problems, like 99% of them, go away when we move into 2-factor. So why don't we move into 2-factor? Well, there's some issues with it, okay? There's usually a cost associated with it, right? Now, not necessarily, but there can be, okay? So let's talk about each one, what we got. Now, you may have these are just your smart cards, pretty straightforward, okay? The RSA token and YubiKey. These are all examples of hard tokens. Now, these are actually the best. If you have this, good for you. You're probably much more secure than anybody just has a password. But the problem with these are they are a physical appliance. You have 10,000 employees, and you have to get an RSA token for everybody. You're going to pay dearly for that, okay? So there's a huge cost. Now, let's say you wanted to give 2-factor ability, but you want to save some money. Well, this is a big one now. I don't want to call anybody out, but most people in this room probably have a smartphone now. Okay, now especially in this room, but in the overall general population, most people still can even get text. All right, so a lot of these tools will actually just text you a number. It gives you a soft phone ability to it. Now, the problem with this is too, what if someone compromises your phone? Can that happen? Yeah, so now they can actually, and there are rats out there that can send back all your messages without them being seen. So think about the machine's affected. They already have your password, but you're 2-factor through your Gmail. But they've affected your phone, now they're sending back both pieces, right? So the hard token saves you from that. You're going to pay more for it. But again, this adds a lot of work for the bad guys. They're lazy. They want to do as least they can to get what they need. I won't say about pen testers, but okay. So, and then last, yeah, right, so we have hard and soft, we're good there. And then, so moving to some of the two-factor authentication that's already been implemented. So if they use web design web services, they use a multi-factor. Dropbox has a two-factor, Facebook has one, Twitter and Google. Twitter, once they just got hacked, they go, it's a good idea, we'll do two-factor now, okay? And we see why, because it works. A lot of our problems go away when we start doing multi-factor. Hotmail and Microsoft moved into a security code, and PayPal have a security key as well. So we see a lot of companies do that. And why? It works. Okay, now this is kind of cool. So if you're into application development, you go, my company wants two-factor, and I'd like to develop that so people can sign into our portal and have that ability. Google puts out an open source project called Google Authenticator. Has anybody heard of that? Good, most of you guys. All right, so effectively it uses two algorithms, both under common RCs, and it has availability, it has versions for PC, Android, iOS, BlackBerry, and PAM. So for your Unix and Linux, right? So this pretty much installs anything. So there's really no excuse for your company or for your web portal not to create some type of two-factor. It's there and available. Okay, now this is kind of cool. I was looking at some new possible technologies for the future of two-factor. And this is something they're doing, I believe it was in Taiwan. They actually have their smart card, they have smart card-based chips that actually have the code, so they act like RSA tokens. So when you do all your purchases, you actually have to put in that token number instead of the 3 little digits on the back. And it always rotates, right? So if they get it, you get your numbers today, they got to actually have the card, which makes it much tougher for someone in China to, or I'm just using China, I'm not picking on them, to use that card and, so they wouldn't be able to use it if they didn't have the card. And this one I thought was really cool. And so this was a authenticator that used your brain waves. Yeah, that's right. So you could use a two-factor here, right? So something you have, your own brain waves, right? So if you're using the force, you're moving something across the room, that can be your login, okay? And it uses EEG or brain waves with this little cool little trick here to make sense of it. So, moving into the future, we may see, who knows what we're going to see for multi-factor, but if this is just used as single factor, we don't get that strength, okay? So what we need to look here is that passwords are a dying breed, but we unfortunately have a ton of zombies walking around, right? It's not there, they're not giving us the strength they used to. However, you do use them. I want you guys to think 12 or 14 characters, beat the tools that will uncover them. Okay? If you can't remember your passwords and you want to use all these tricks, that's fine. Write them all down, put them in a safe. Okay, at least you got them in one physical location. All right? But effectively, if we do all these things, we see that all the problems that were going on with the network intrusions go away. Two-factor solves most of this. Okay? So kind of a call to action to think about anytime you can, move to two-factor. If you can't, make sure you guys have passwords that are unique for each of your sites. And make sure you have the complexity, the length. If you guys are admin, make sure that you guys are doing things like, can you guys enforce password policy through any system? Absolutely, right? You can do it through PAM or through access control information, right? So that's good stuff. All right, so there's all the links. You guys can reach me if you guys have any questions external today. I'm going to go into questions here in a second. You guys can reach me at rabbitsecurity@gmail. I'm also on Twitter at rabbitsecurity. With that, I want to open up the floor to questions. Anybody got any questions, concerns, complaints, holy complaints? Yes, sir.
Just a note on biometrics. I've done a lot of work there. When you use biometrics for authentication against information security systems, it actually doesn't add any security because most applications don't know what a biometric is. So they just encrypt the password in the local cache. Sure. So if you are actually
two-step versus two-factor, effectively.
Yeah, I mean, if you're attacking the actual application and the passwords, it's still dependent on the password.
Yeah.
So it adds no security, and there's a lot of confusion because in physical access, the readers on the doors actually do match the fingerprint template. Yeah. It's not the case with information.
Yeah, you guys heard they just hacked the new iPhones come already. You guys heard that? The Chaos Computing Club already spanked that process.
Yeah.
So and again, so when you guys get two-factor, I would definitely, like RSA, the hard tokens, the soft tokens, I would argue is a much better chance. However, just by even doing two-step, we get some type of addition to it, especially because unless they are grabbing it remotely, there has to be something locally, biometrically, that is causing that data to go in, right? Right. Put a thumb in there? No? Okay. Question?
Just a footnote on that, usually your thumbprint or whatever your biometric signature is hash.
Yeah.
And if that hash is cracked, you can't change your thumbprint.
That's true.
Or your record.
That's true. Yeah, they only got 9 more tries.
The other thing is the smart cards, you have to sheet them in this Mylar sheet.
Yeah. They just saw another one where they were sitting people on a couch and they were reading their cards, you know, just sitting on the couch. I don't think I saw that one. Any other questions? All right, well, thank you.